Hola amigos, ahora vamos a aprender sobre infraestructura como código y Terraform, and that's all. Okay, so that's pretty much my level of Spanish, and thank you to Duolingo for teaching me. I have to talk about Terraform, and I can do this pretty much for a long time. I've been doing this almost professionally since 2015, and I so far enjoy it. I also enjoy kind of making a lot of open source activities like Terraform AWS modules, which I'm going to cover today, but also some other utilities, and pre-commit Terraform is one of these utilities. Actually, a funny fact about Barcelona, I have been in Barcelona, I don't know, no, not Barcelona, in Madrid, in Spain. And I started working on Terraform best practices 4 years ago. It has been translated to Spanish, so if you want to learn Terraform best practices, please go to the website. And you can read it in Spanish, and hopefully it will be useful. What else I want to highlight out of a bunch of different projects is, when COVID started, I didn't go pretty much anywhere, so I decided to share my knowledge through different media. So Terraform Weekly newsletter is what I'm sending every Wednesday. And also a YouTube channel, just because I think it's fun to produce something and not edit it. So if I say something stupid, then it will be live forever until YouTube blocks me. So far, I have not been blocked. But please subscribe and stay tuned for that. My talk is about Terraform AWS modules and pretty much the journey which I've had through that. For those who don't know what is Terraform AWS modules, well, actually, why I'm talking about this? Please raise your hand if you don't know what is Terraform AWS modules. OK. Cool. So a few people don't know. Great. So then you can read this slide. OK? So Terraform AWS modules is a collection of open source modules which were provisioned many times because they are very kind of generic and they satisfy a large amount of customers and large amount of needs. A couple years ago, I decided to focus on serverless because it was hard, and then I kind of published serverless TF as a framework as kind of next step. So that's pretty much what Terraform AWS modules. There are many people who are sponsoring my work, and thanks a lot to all of these companies and individuals, because that's pretty much what pays the bill. Well, there are two types of developers, as I like to say, is that there are developers who are trying to make their life harder. They're going to documentation of Terraform. They're reading about individual resources, learning the peculiarities of different Terraform features, and so on. And other people who have discovered existing packages or modules, they use it, and they happily move forward. So decide yourself which group you want to belong. None of this group is better than another, but there are just two groups. So why do developers actually like these kind of projects? Well, first of all, it's definitely a very large community. And a very large amount of features are actually shown in examples. So you don't have to think about, oh, my God, what I'm supposed to be doing here. And often people are struggling with documentation. So documentation is automated, and a lot of things are actually described in pretty human-friendly language. So that's really important that when you are getting started, you already have everything what you need to get started. And we also try to utilize the same patterns so that all of these modules are interconnectable and they have very similar user experience. If you are using one, you will most likely have no problems with using many other. Talking about clones, as I have discovered recently, it's about 70. No, it's about, well, you can see how many is it. It's a lot of people. It's a lot of people who are relying on this stuff. So that's why some things which I'm going to talk about is actually based on experience. If you don't have projects which are so much kind of on demand, your expectations may be delayed. For example, if you introduce some bug with this project, it takes half hour, 10 minutes sometimes, to have a full email with complaints from everybody from around the globe saying like, oh my God, you broke my production. Sorry, but that's live. So the agenda for the talk, which I want to kind of go through, is actually divided into several sections, starting from how it has started, and then I will explain my initial vision when I started it in 2017, and then how I was actually trying to scale, how to engage more people, and how to build it a little bit quicker and more efficient, because it was just necessary at that time. And I also want to, at the end, I want to emphasize and explain which of these lessons I'd like you to think about introducing in your setup. So it started back in 2015, where Terraform Community modules were created by some HashiCorp employees. It was very early days in Terraform Community, which started 2014, and this project started 2015. There were some very interesting kind of initial greenfield setups where we saw that some modules were actually forked more times than features in the module itself. Can you imagine that you have, let's say, one text file with 20 lines, and it was forked 100 times? What people can change in these 20 lines more than 100 times? So there was obviously a problem with reusability. A lot of things were hard-coded, and it was obviously that it's not reusable because people are forking it all over. So then 2017, Terraform registry was launched. It was Terraform 0.10. And very early days, I understand that, OK, reusability is important. So then I start to think about Terraform AWS modules as libraries. That's like the only thing which I knew, because I come from software development, and I knew that libraries are good. So there has to be some libraries. So I have to think about software development principles much more when working on those. And then version 2 had a little bit other goals, because I already saw that, OK, people are starting to using it, but they sometimes may be overwhelmed with the complexity which they have. So that's why I was already thinking about how to hide the complexity far away from the user, because I don't want users to know how bad it's actually written. For them, it should look shiny, and everything should work, and there has to be really a lot of hacks implemented inside. Again, it was 2018, 4 years ago. Terraform was not so powerful at all, so we used to introduce a lot of different hacks. Obviously, then the next step comes when I start to understand that it's impossible to kind of ask people to contribute and then discuss in all pull requests that this is a wrong name, or please don't use this variable, use that variable. So naming of variables and outputs was taking a lot of time. It's like if we would talk about spaces versus tab in Terraform, that's what we talk about name for the resource. So around that time, I decided that, OK, if there is no best practices, because people say, oh, it depends, I hate the answer, it depends, in pretty much all industry which we are at. So that's why I say it does not depend, because it's already on Terraform best practices. So I wrote it there, and I said, like, OK, this is how it should be called. I explained how different variables and outputs and other things has to be named. Some people disagree. They say, no, this is not best practices, but at least we start discussion. So that's what I wanted to initiate. Again, it was 4 years ago. So then, obviously, things like changelog and some manual automation using some make files, some documentation generation, all of this has started to happen because there was need to have more people participating. And I want to have significantly better quality from everyone. And again, it was an attempt back then that, hey, what about infrastructure testing? Let's add kitchen Terraform. And it's funny enough, but a few years later, we discovered that, oh, in one repository, we actually have infrastructure testing, but no one ever executed it for several years. So you can imagine what kind of tests were there. So we obviously removed it, and nobody noted it. So then the next challenge was like starting up, because a lot of features which are recommended by the user are usually very specific to their use case. And this is something what I have to, unfortunately, I'm not able to find like automated template by saying like, hey, this stuff does not belong here. Please never, ever open this kind of pull request to these repositories. So I have to write something really polite and like, oh, you know, this is how resource modules are supposed to be operated. Again, I described this on Terraform best practices in more details because I wanted people to read it, to understand it, a little bit more context then. Well, yeah, people often contribute something what is really, really specific to their use case. Many people don't care about compatibility, about like canonical solution for different problems. So every time people solve their own problems, and I used to kind of highlight that this is not going to survive. Please don't write it this way. And again, helping of adopting more tooling like TF-lint, CMTag, or doing even code reviews for something what has been created between different people, not just me looking at this and saying like, sorry, it's good or bad, but actually trying to involve different people was very important, because that time we were able to actually figure out that some contributors are very good at providing feedback. So it was my pleasure to just discover these people and tell them, please review this pull request, because I know that you know the subject and you will be able to provide very good code reviews. And again, Terraform 0.13 started or was added around that time, and we were trying to figure out what kind of version should we support, Terraform 0.11, 0.12, 0.13. For a short amount of time, we tried to support several versions. It was nightmare. Like, it was probably the worst decision which I have ever made. So we decided that, OK, from now on, we use only Terraform 0.13. We're not using anything like cool and latest features of Terraform, because we want to satisfy as many users as possible. So up until recently, most of modules which we have required Terraform 0.13, which was developed 4 years ago or 3 years ago. So the scope which we wanted to put in the modules was pretty much 100% of flexibility. Everything is supported. No hard-coded use case for specific user, but for everyone. And we wanted to cover as many possibilities as possible. Also, we clearly rejected all extra specific features which people sometimes wanted to have in the modules. For example, people wanted to add provisioners or wanted to add third-party modules or some extra other providers. We just rejected all of this, because internal scope of the module which we developed was something what people can utilize in very large amount combination. And around that time, it was very obvious that we need to separate that there is a resource module for the individual resource, and then there is something what is like second level, which is infrastructure module or composition or stack. Now there are so many different terms that you really, when you're talking about this, you really need to question like, okay, what do you mean by stack? Because in many setups, people think about stacks differently. But what I like to think about this is that you always have resource modules on the very bottom, and then you group them somehow, and you figure out that, OK, this is my infrastructure module. So I don't know, what is this slide even about? Yeah, who wrote this? Yeah, well, the last point here is really important. Is just to stick to the core features of Terraform. So there are no crazy features which exist in Terraform, but we may have some benefit because we will save 20 characters. Well, it just doesn't make sense. So that's why there are no workspaces, no overrides, no provisioners, no code generation, nothing really. It's just basic plain Terraform, which was written, as I said, in most cases, which was written 3 years ago, and it still should work. Well, then I also thought about what are actually traits of good Terraform modules? Because when you look at something, let's say at your work, you may think about first thing which I need to add is infrastructure testing. Why? I don't know. Just because, why not? No, actually, the first thing is you're writing it for the human. Humans like to read documentation and see example how things supposed to be used. This is number one of everything. Then people, as Hila mentioned already in her talk, that good open source projects are really feature rich. So there are all features covered, preferably including your use case, but maybe even something for the upcoming things which you're going to need in the future. Also try to not have really strange default values inside of your modules just because you think that default equal 5 is good value. Well, let user decide what is good. And don't make it so hard for user to change it or to override it. Writing clean code is maybe a little bit sound like cliche, but it's really to the point that when you're writing good Terraform module, you should have only what you need to have there. Don't try to impress everyone who's going to read your code by the amount of Terraform functions which you can put in one line. It's impressive, cool, we can work together, but that's it. It's not really the purpose of, it's not purpose of the module. Try to write it really, really clean. And the last point here I put as tests because if you have already good documentation and example, tests are not really that necessary. I mean, yes, they're good. They will solve and they will help you with a lot of things, but they're not really so much relevant. That's why you may think Terraform still doesn't have a decent testing framework. Yes, there are a bunch of them, like Terra Test or Kitchen Terraform or even more, which you can make as an infrastructure testing. But they're not so much needed right now. I will try to explain this a little bit in detail later. But actually, I'm here for 2 days, so if you have any questions, just come and talk, because I may have a little bit more information than I put on these slides. So one helper tool which is currently in use by, well, maybe thousands of people. I don't know. I search on GitHub, and there are quite a lot of references to these projects. So I think people are using it because people want to have their code formatted, documented, validated, linted, and other things at the same time before they are actually pushing it to the repository so that their colleague start to think about this and start to tell you like, oh, why you are even asking me to review the code which is just invalid, which does not work in any way. So that's why this collection of pre-commit hooks were developed like a long time ago, and I just see that people are still using it, so we added many, many more hooks there to, for example, to calculate cost, because you may not want to even commit code which is going to be expensive. So these kind of checks we already put into pre-commit Terraform hooks, as well as running a bunch of different security analysis tools and few more. So it's open source as pretty much everything what I'm showing here. So if you want to take a look there or you want to contribute, I cannot stop you. So maintaining and learning lesson, I can definitely highlight that when things are simple and standardized, it's much, much easier to discuss. You don't have to talk to people about simple things, but you can actually spend meaningful time discussing the problem which people try to solve. When things are standardized, you again don't have to talk about why you name these things in camel case. Well, because I'm coming from Azure and we don't care about case. Sorry, but that's bad explanation. So sometimes we used to reject even more good solutions just because the complexity which will be introduced to the module is very, very high. So I sometimes look into like hundreds of lines change, and I think like, well, that's very good attempt, but probably it's just for subset of users, and it will increase our amount of complexity so much that we just don't want to maintain it. So please fork it, maintain your fork, or re-architect it a little bit differently. And as I mentioned already, the documentation and the example are really meaningful. The easiest solution which I want to kind of, not solution, the easiest hint which I want to give is always think from the user perspective. Not try to impress like, hey, this is how cool I know Terraform and that's how crazy code looks like. No, think about user. What user wants? Well, user wants to create some sort of resource. Great, so what do we have to do from that? So always start from examples and think about how your interface will look like. And develop only for real customers, for real use cases. Never try to over-engineer it for the future yourself or for potential customers who will discover this code. One example of this is Transit Gateway module, which I have developed for one customer, and I have never, ever used it since that. It's an example of a module which should not be created. Take a look there and learn how things should not be done. Amount of complexity there, amount of limitation, and amount of strange decision which I put there is just a little bit too high. So it should not be created this way. But again, it worked for one customer, and customer was happy, and then that's it. But it's not applicable for more than 2 customers. That's not a good use case. And constant challenge is just involving other people and maintainers and reviewers, why people should do this. Like, when I ask anyone from the community and say, like, hey, can you review this, or can you do something about this, or what do you think about certain improvement, I usually have very good feedback. Very few people say, like, sorry, but I don't have anything to say. You know, if you ask people very precise question, or you know that this person has experience with utilizing this module or this service, then they usually have very good understanding of everything what can be utilized, especially in code reviews. Obviously, none of us can know all AWS services very well. That's why we sometimes rely on different expertise, and involving people is really important. You may think about, what about testing, right? Who cares about infrastructure testing? Oh my God. Why? Why? OK, yeah. Well, for the record, nobody raised hands. Nobody. OK, some people. No, actually, more than half of you raised hands. So the reality of infrastructure testing is, I mean, in Terraform AWS modules, and pretty much in the whole Terraform, is like this. There are so many people who will not do what you tell them to do. Like, they say, like, oh, we like to run everything from the master branch because, well, what can possibly go wrong? Half an hour for, I think it was security group module, which the whole thing was maybe 2, maybe 3 years ago. So I pushed it, and it was just broken. And then in half hour, things were pretty much viral. People will, oh my God, it broke everything. Well, sorry, but that's how I test. So, no, actually, there is no better way to do it. Still, I mean, maybe it sounds funny or something has changed. No, not really. I mean, there were several attempts from the community, from HashiCorp. There is a Terraform test command which you can run, but it doesn't work. So yeah, you can run it, but it doesn't work. So that's why it's better to think about static code analysis, TF-lint, whatever you can do on your local computer a little bit more, and then push it. Maybe not to the master, but maybe make some pre-release tag or do whatever strategy you prefer. But again, testing is hard because, well, just because it's hard, right? And I think that it is hard because, like from the expectation point of view, who are going to contribute to test? Well, it's probably people who are using some Terraform and they know some HCL. By the way, who knows what is short form or full form for HCL? Yeah? No, that's wrong. Not HashiCorp configuration language. It's human configuration language. So that's because it's supposed to be written so simple that people should just read it and understand it. We cannot enforce people from all language experience, from different countries, from different, I don't know, different backgrounds, to suddenly force them to use Go and write Terra test. It just doesn't work. I mean, I saw many companies who say like, oh, we will introduce Terra test, everything will be fine. 2 weeks later, no new movement happening because it's just hard. I mean, yes, you can write something simple, or you make happy pass test, everything looks good, but the reality is that testing is for developers. It's not for your end users. That's, again, my observation over many years, and that's one of the reasons why we don't use Terra test for Terraform AWS modules. We can also think about ISC testing pyramids, where we have a lot of like low-level tests, where we have some sort of static code analysis or synonym like unit test in software development. And then we have long-running test and then end-to-end test on the very end. So this is kind of how pyramid looks like. In reality, we will have significant result if we just focus on static code analysis. Like my favorite is TF-Lint and Terraform Validate. If these two tools combine together for Terraform AWS modules, we usually catch 90% of bugs quite effectively. And again, we do this in pre-commit phase, so we run it every time when we commit something. If we are able to run Terraform plan and Terraform apply on example, again, without checking the result, like what exactly has been created, it's 95% of success, and we are usually very happy with it. Again, some of you may think like, oh my God, we are happy with Terra test. I'm really glad that you are happy with Terra test or any other framework. I just cannot see how Terra test can be introduced to the community at large, especially for very different type of people. But if you are developing your infrastructure modules and you want to test something together, like not just small units or resource modules, but a little bit more interconnected things, then Terra test may be beneficial, but maybe. In Terraform 0.14, I think, there was first introduction of Terraform test because, well, as I believe, writing human configuration language to assert code is the right way, because human already writes HCL, then running Terraform test should be a very native thing to do. But actually, behavior-driven development, which we had in software development for ages, is also not a bad thing, because we want to be able to describe our scenarios, and we want to run some framework which will just assert that certain things were created as expected. So that's one of framework which is called Terraform Compliance, and I think it's quite good for that. But more specifically, what we are able to utilize right now, and exactly in 2022 or upcoming year, is utilizing more open policy agent ecosystem. There are no framework as of yet, but around open policy agent, you can build quite sophisticated testing capabilities. We'll see if it will be public and if it will be released, but I know that some companies are working on this in-house, but they are not quite there to release it publicly. And also consider using local stack, because you really want to be able to produce your infrastructure and run tests with as little dependencies to the external world as possible. And you want to run them as quick as possible. So local stack is actually one of the sponsors of this event, and they're doing a very good job in teaching in the way how you can look into your infrastructure testing and run infrastructure not on real AWS account, for example, but on your local machine. It's enough functionality if you are going to use it for your test. Obviously, you cannot run production there, but for test, it's probably good. Some future plans. As I mentioned previously, that developing testing framework for Terraform modules is actually somewhere pretty high, like in my personal list, because I feel that it's probably a cool project to kind of dive into and see if there is such need. Because writing Terraform modules, pushing it to some master branch, release it, and fingers crossed, and then say like, oh my God, hopefully I didn't make any mistake. That's what I've been doing for many years. But maybe there is a better way. So that's why I'm looking into auto-generated IAM policies, which are required for the Terraform modules using Pike, or there are other projects with a similar purpose. It's really important that when you have a module, you already know what kind of permissions you are required to have. Many of us are using some wider permissions just because we don't know what exactly is necessary, but it can be a good idea to provide a document which will tell, in order to run this module, please use this permission, not your admin permission as you've been doing before. And yeah, I've been trying with everything as code for a bit, yeah, I think more than 3 years now. It was good, but it was also bad because it was over-engineered. Again, this is meta repository, which you can look into example of how over-engineered Terraform can look. Don't do this. I regret about this. But nevertheless, it was fun. And yeah, maybe you like fun as well, so please contribute. And yeah, continue with dog fooding is another principle which we utilize inside of Terraform kind of ecosystem at large, is that we're not writing some software and then just ship it somewhere and we never use it. We always utilize stuff which we use. Like in all projects where I work as a consultant or if I'm helping with something, we always use stuff which we develop. Like if there is something what we can improve, we improve it in the open source. And then we use this version. A lot of companies, like big banks or whatever, they are using modules, but they are sometimes downloading them locally just because they don't want to go to the internet. But in general, it's the same modules as the rest of us have in open source. And serverless TF is another direction which seems to be interesting for many people because, well, just over a few years, we figure out that dealing with serverless on AWS with Terraform is kind of hard because it just doesn't belong there, and sometimes we want to have a little bit different kind of user flow and different experience, or we think that things look a little bit too complicated. If you think that something is a little bit too complicated, then it is complicated, right? You are thinking about YAML now, Kubernetes, right? It's complicated. That's why it shouldn't be so complicated. So think about how you can improve it. Like I know that Victor delivered a talk before, and it was great, but he's expert. None of us are expert of this level, right? Yeah. No, you are. You are. OK, so what can you do? Well, Amazon leadership principle. I know that it may sound a little bit kind of, yeah, what do you know about Amazon? Well, yeah, I don't know enough about Amazon, but when I read these Amazon leadership principles, and I like certain points there, like customer obsession, that's pretty much what I believe a lot of us will have pretty good success if we just follow those. So what it means is that we are thinking about customers, and we are actually working towards satisfying the customer needs. And when it comes to the intention, some of you may think like, oh, I have my infrastructure documented because it's infrastructure as code. We have heard similar points by Hila in the previous talk. Always try to document intentions more. Not like what you have created and then you think like, oh, that's end of the day. No, try to explain it. Try to think about how did you actually come to this conclusion. Try to provide as many links as possible. So when your documentation looks like a bunch of different links to the external web, it's so helpful that you cannot underestimate it. Always, again, think that your users will be people who actually may not have even infrastructure experience in the past. They will probably use your stuff inside of your organization, maybe for the first time, because they are, let's say, front-end developers who just want to create S3 bucket. Do you want them to know that S3 bucket consists of 15 resources in Terraform? Probably not. That's why use modules instead of going to documentation and struggle with understanding it. And yeah, always try to understand the structure of an existing solution before you can just copy and fork everything just because we can, right? A lot of organizations first go to the open source project and then they say like, oh, that's too complicated. I can fork it and modify it for my needs. Well, you can. I'm not against that. Many companies are doing that. But just try to understand what is there, because there were several thousands of hours put into the solution, and if the solution works for many other customers, maybe it will work for you too. And when you are coming from the software development background, you already know that libraries are good because, well, I don't have to study the library if I just want to use it. The same goes with Terraform modules. So the complexity is somewhere inside of it. And if I can read example code and I can execute it, great. That's exactly what I want to do. I don't need to know right away how things are built inside. If you want to contribute or if you want to be a good citizen in the open source community, please don't write code, OK? Go to the issues. Try to understand what people are struggling with. Try to resolve existing issues. It's an enormous amount of help when you are going to do this. Few people say like, yeah, but my code is so awesome, I will just push it. Please don't. Because very often people push code and then we have to go through the loop of like, oh, this code is not good, it doesn't work because of this edge cases, and so on. Or, by the way, I fixed this issue, and I fixed this issue, and by the way, I think this is also cool. Again, 200 lines of changes is usually a bad idea. So always change as little as possible. This is extremely important. And I have to say that we are using a lot of automation. And previously, before automation, I was bad guy. Now we can blame Slack. No, not Slack. Stalebot, because Stalebot is closing issues after 30 days of inactivity. And people are complaining against Stalebot. I'm happy for that, really. That it means I'm not the bad guy anymore. Yeah, if you have any questions, just ask. I still have 7 minutes. He has a question.
Yeah, we have a lot of them written down here. Thank you, Anton. There are quite a few. Let's try to group them a little bit. Let's start with the philosophical one. Well, maybe not, but yeah. So people are asking, like, what are your thoughts in terms of the future of Terraform and infrastructure as code, generally speaking? Probably a question we can put to Armon later, but yeah.
Yeah, well, Terraform versus NSNL. So this is a pretty common question, I would say, like, especially when people are reading news and they say, like, oh, this another company started, this another company is doing something. The main point of Terraform and why it exists is that it has very big community. It has a lot of solutions already developed. It's just unlikely that you will be able to pick up tool of the month, which started, let's say, last week, and you will be productive. You will have to spend significant amount of hours just to kind of build on the same level. So I think it will survive for a pretty long time. Otherwise, I wouldn't be standing here. I would probably use another tool already. So.
Right, so now, like comparing with other tools in the ecosystem, people are asking, like, okay, so there are other tools like Ansible, which have a degree of like overlap, let's say, with Terraform. When should we still use probably Ansible or like the overlap comparing? Like?
Well, yeah, the use case for Ansible and Terraform has not changed since the creation of Terraform. Terraform started as infrastructure management tool. So first you need to create infrastructure, and then you need to run your Ansible somewhere. Of course, you can substitute, you can integrate them in different ways. But the point is that Ansible is still the best when it's running on the server somewhere, or making some other things, but inside of server, while infrastructure has to be provisioned before. So use cases that you spin up your instance and then Ansible is provisioning some configuration or doing something when you are building images has not changed at all for the last many years.
And then, like, not sure if you are like very proficient with Pulomi, but people are asking if there are any like features that Pulomi has that Terraform does not, and you would love Terraform to have it.
Yeah, well, I didn't check the recent announcement, which is supposed to come today or tomorrow, but they say it's going to be the biggest announcement ever. We'll see. I don't believe that it's going to kill Terraform tonight. But anyway, the point of Pulomi is still that they're doing a lot of good stuff, but they're doing it for slightly different reasons. So Terraform and Pulomi, you can compare them, and you can use them equally successfully. That's not the limitation. But I don't think that Pulomi suddenly will take the whole market or do anything significant damage to the Terraform ecosystem. It can damage themselves, check Twitter, but that's it. There is.
And someone else in the audience is asking about Terra Grant. Your thoughts on that? Sorry for asking about.
Yeah. Well, yeah, I think it's actually the first time when I never ever mentioned even Terra Grant in a talk. That's my achievement. Because I have been using Terra Grant for many years, and this is one of these tools which supposed to help you with managing complex infrastructure with a lot of environments, with a lot of dependencies. The main, like, I was advocating, and I'm still advocating to use Terra Grant for real projects. But I regret that I recommend it, because I don't think that such tool has to exist as a separate tool. It has to be minimized, and it has to be incorporated into Terraform. Like, I don't know, 20% of Terra Grant should be inside of really Terraform core, and that's it. The goal of Terra Grant, and well, it will be needed if you are making large usage of, let's say, different environments with different modules, with different, configurations. Then it's really useful. And as I say, I have been using it, happily using it for many years, since 2017, and I still use it pretty much everywhere in the default project. But there are a lot of limitations, and every time I think, like, should I start this project with Terra Grant? I look into the scope, which is like TerraMate, TerraSpace, Terra Grant, and every time I say, like, still Terra Grant is the best one. So TerraMate is something what is already public. It's already, like, according to the developers, they say, like, we are not competing with Terra Grant. Well, I don't believe them, because, well, everybody wants to take part of the Terra Grant. So if you are happy with Terra Grant, take a look into TerraMate and TerraSpace.
And slightly related to that, people are asking, like, any other tips to improve the speed for a Terraform plan with a lot of resources? Terra Grant can help a little bit, but any other tips you could share, aside from breaking it out into different smaller?
Yeah, well, this is definitely the issue if you have a lot of resources. Like, one of example is DNS records. You have one zone, and you have thousands of records in it, and you want to manage them somehow. So I think after about 1,000 records, you will have hard time to run plan, and it will be just slower. So I don't actually know a better solution than just try to split your state file in many different ways. There is no magic solution which can help you with that.
Right. So there are a number about testing, really. I think local stack is here, so probably it comes from them. What are your thoughts about using, for instance, local stack with a local Terraform, like, you know, trying to point it to there and then as a way to test?
Yeah, local stack here is definitely one of these things which potentially supposed to reduce external dependencies. So you don't have to have internet. You can run it on your local machine, and everything will be quick and cheap. So, like, all benefits, right? Of course, it's not so obvious that, I mean, if it would be so simple, then why do we have even AWS, right? We can just all, like, local stack and everybody is happy. No, the reality is that there are a lot of missing features in all of this, like in Terraform provider, in AWS provider, in local stack, and all of these are different versions. So when you're looking into running tests, you will have significant kind of guarantee that if things work with your local stack and you're using like basic servers which are very well tested, then everything will be fine. But if you're using some latest edition of AWS servers which will be announced at reInvent, well, probably it's not going to work well with local stack. So you need to be careful and read documentation very well. Yeah.
And the last one, because we're literally just running out of time. Not sure if there's any sponsor for that here, but people are asking if, besides having Terraform AWS modules, you would have Terraform Google Cloud modules or Terraform Azure modules or potentially any others.
Yeah, that's a good question. Actually, it was not coming from the cloud providers. Like a few years ago, I had discussion with some of cloud providers, and because I wanted to tell to them that, hey guys, I can do the same stuff for your cloud providers. And funny enough, but all of these providers, not all, but just 2 of them, who I reached out and I proposed, they say like, no, this is community work. So community should come up with this stuff. We're not going to kind of sponsor or support. And believe me or not, but this is exactly the same situation right now. Do you know of a lot of Google or Azure modules in the community? Well, not so many. They are existing, but they are developing on very different pace, very different incentive. And funny enough that some of these cloud providers told me a few years ago that, well, this is just text file. Come on, what are you trying to even sell us? Like, yeah, it is text file, but, you know, yeah.
All right. Thanks a lot, Anton. Thanks a lot for coming.
Yeah.
Thank you very much.
Thank you.